Hello and what's up, everyone? Today we are doing our last part of our final review. This is it. This is the last little bit of information, and then we take our finals and we're done for the year. We're almost there, so let's grind it out. So first up, we have a dilation problem. Remember, a dilation is a stretch or a shrink around a point. So when that happens, it's going to push away things, which would be a stretch, or draw things towards it, which would be a shrink. So for this one, it says an image will undergo a dilation centered at point B with a scale factor of 2. For the problem that we have, it doesn't matter what the scale factor is. What matters is the point B part. So at point B, so point B here is our center of dilation, right? So it's going to take all these points and push it away, right? So whatever line that point's on, it's going to stay on that line, but it's just going to get pushed away, right? It says then which lines will not be changed by the transformation. So which ones will be in the same spot, and a line goes on forever, so you can't stretch it really, or you can't really shrink it, because forever is always going to be forever, whether you stretch it or shrink it. So with that in mind, the way we could tell this is the lines that go through point B will not be affected because it's just going to push things along that line anyway. So for instance, A is going to be pushed out on this line here. So no matter where A lands, AB will be the same, right? So we have to look for lines that are on that go through B. So AB, which is also known as AC, is one of those lines. So that's our first one here. So that one will not change, right? It's going to stay exactly where it is. Let's look at AE. AE is right here. AE does not go through point B. And what will happen at AE is it's going to be pushed down this way, right? Away from point B. So that one will change. So we're not going to select it. BE. BE goes through B again. So will not change. We're selecting that one. CD. CD is not going through B. Once again, it's going to be pushed away from point B. So we do not select it. And last but not least, DE. Once again, DE does not go through B, so we will not select it. So our two answers here are AC and BE. Both those lines go through point B, which is the center of dilation, which means that those lines will not change. On to the next problem. The next problem says the figure shows line AC and line PQ intersect at point B. A prime, C prime, and line P prime, Q prime will be the images of lines AC and PQ, respectively, under a dilation with the center P and the scale factor 2. And we want to know what's going to happen with those lines. So line A prime, C prime, right? So P is the center of dilation. That's one thing we want to keep in mind, right? So AC is not going through P, which means it's going to be pushed away from P this direction, right? So, right? It's going to be pushed down away from it. So when that happens, it says AC will be parallel to AC, perpendicular to AC, or the same line as AC. Well, it's not going to be the same line as AC because it's going to be pushed down. And now when it's pushed down, we're not rotating it out at all, right? So it doesn't mean that it's going to be pushed away and rotate it so that's going to cut through AC, the original line. So our answer here is it's going to be parallel. And that's true with any line during a dilation, right? If the line is changed, it will be parallel to the original line. So your new line will be parallel to the old line. That's one thing to keep in mind. But now look at PQ. Line PQ goes through P, right? So what's going to happen, as we said in the last problem, it's going to be the same line. This one's nice and easy for us. Whoops, I accidentally deleted my box. So it will be the same exact line. That one's easy. It will not change because even if you dilate, no matter what the dilation is, it will stay the same. Next up, it says segment QT as the endpoints -10, 5, and 0, 15. The segment is dilated about the origin by a scale factor of 0.6 to create the segment Q prime, E prime. What are the two endpoints of segment Q prime T prime. So this is super easy because of the fact that it says it's dilated by the origin. Our rule for this one is we just take our original points and we multiply it by our scale factor. So for this instance, our scale factor is 0.6. So I'm just going to label everything though. So we use the letter K to denote our scale factor. So I'm going to put K equals 0.6. I'm going to put my 2 points, -10, 5, and then 0, 15. And then all I'm going to do is multiply both these by 0.6 times 0.6 times 0.6. And we're going to do it for each point, right? So first up, we're going to do -10 times 0.6. So let me get on my trusty dusty calculator. So 10 times 0.6 is going to give me a -6. -6. Right? Because a negative times a positive is a negative. And then 5 times 0.6 is going to give me 3. Boom, boom. So our first coordinate is -6, 3. And our second coordinate, anything times 0, 0. So that stays the same. And then my next point, 15 times 0.6 is going to give me 9. So we'll get -6, 3 and then 0, 9. And there we go. We finished. We got our scale factor. I mean, our points after dilation. Sorry, using our scale factor. Next up, it says in the figure shown, the lengths of the segments AC, BC, CD, and CE are given in terms of the variable x. If AB is parallel to DE, solve for x, determine if the dimensions are reasonable. So what we could do is, since we know that these lines are parallel, those arrows mean that they're parallel, we can then say that angle A is congruent to angle D, and then angle E is congruent to angle B, right? And then we could say, finally, these two are congruent, which means we have angle, angle, angle similarity. And if these are similar, we could then set up ratios. And the ratios will be AC over BC is equal to BC over EC, right? Now notice AC and BC are from the same triangle, so they're both up top. They're buddy-buddy. And then DC and EC are from the same triangle. They're both down below. So let's plug in numbers for those. AC is the value x. DC is right here, is x plus 2 equals BC is x plus 3. And then EC is x plus 4. X plus 4. Now, what we have to do is we have to cross multiply. So first up, let me change colors. We're going to do x times x plus 4. So we get x times x plus 4 equals. And then we do x plus 2 times x plus 3. X plus 2 parentheses times x plus 3. So now when we multiply these things, there's one thing we have to remember. When we multiply a variable times itself, it's going to give us a square of that value, right? We just make a whole different color. So we're going to get x times x, which will give us x squared, and x times 4, which will be 4x. And remember that we have to distribute here. On my other side, we have to do FOIL. First, outer, inner, last. So x times x will be x squared. And then we're going to have x times 3, which will be plus 3x. Now 2 times x will be plus 2x. And then 2 times 3 will be plus 6. Now I'm going to rewrite this up here, but we're going to simplify it, right? So my left side could stay exactly the same. X squared plus 4x equals my right side. Sorry, my left side stays the same. My right side is going to become x squared. We could combine our two middle terms. 3x and 2x will give me plus 5x. And then finally, plus 6. Now, one thing we notice is both sides have this x squared. So what we could do is we could subtract x squared from both sides, and it's going to get rid of it. They cancel each other out. And then we're left with 4x equals 5x plus 6. Now, last but not least, we want to get our x's together, so I'm going to subtract 5x from both sides, and that's also going to leave my plus 6 by itself. Right? That's going to give me a negative x equals 6, or in other words, x equals negative 6. We figured out what x is. Boom, just like that. Now, our last question, or the second part of this question says, determine if the dimensions are reasonable. Well, let's plug it into one of these, right? So I'm going to take my x plus 4. So x plus 4. And then if we know that x equals 6, we could plug it in. So we get negative 6 plus 4. That's going to leave me with a negative 2. Now, the problem here is, can we have a negative value for a length of a side? The answer is no. So, no, not reasonable. Boom. So, they're not reasonable because we get this negative value here, and x is negative 6. So, those would be your two answers for this problem. And justifying your answers by doing this work. Next up, which transformation on image A can be used to verify that it is similar to image B? This one's super easy. We just have to identify what's the transformation that's going on. Well, our answer here is, look, we have a bigger shape and it turns into a smaller shape. There's only one transformation that does this, and that's a dilation. Exactly what we were talking about before. Now, one other thing that we want to do is figure out, hey, what's the scale factor of this dilation? So what we could do is we could take points that match. So I'm going to look at B and B prime. And if we look at the y coordinate, 6 and 3, all we have to say is, what is 6 divided by 3? It's going to give me 2. So that's my scale factor. So we could say k equals 2. So it's a dilation. Actually, sorry, did this the wrong way. Shouldn't be 2. It should be the other way. It should be 3 over 6, because that's our new point. It's the new point over the old point, which would then be 1/2. So our scale factor is 1/2, which makes sense because it's getting smaller. So a scale factor of 1/2, which is a fraction or a decimal, right, is getting smaller. It's a number less than 1, which means a reduction. Next up, says the figure shows triangle ABC. Segment DE connects the midpoints of respective sides, AB and BC. So this gives us our mid-segment theorem. And it says, is it possible to prove that DD over DA is equal to DE over AC? So what we want to do is show that they are proportionate. So one thing that we can do here is say, hey, we know that first step, we're going to say, hey, DE is parallel to AC. That's one thing we know, right? And that's our mid-segment theorem. That's step one. Mid-segment theorem, those are two. Boom. That means these are parallel, right? Which then means that angle angle B, whoops, B, D, E, congruent, angle B, A, bro, my brain's not working, BAC, there we go. Also, angle BED is congruent to angle BCA. And both of these are true because they're corresponding. corresponding angles. My handwriting is horrible today. Sorry about that. And then number 3, we could also say that angle B is congruent to angle B right at the top because of the reflexive property. Reflexive property. Then finally from there we could say, hey, well, that means that these triangles are similar. So triangle BDE is similar. That little squiggly means similar to triangle BAC. Why? Because of angle, angle, similarity. And last but not least, we can now say what our proof is, that BD over DA is equal to DE over AC, right? And why? Because it's a property of similar triangles. So it's a property of similar triangles. There we go. We proved it. I know there's a lot going on here. So just if you're confused about this, just watch it back again. And if you need more of an explanation, drop a comment on the video, or don't be afraid to ask if you're in my class. Next up, it says right triangle ABC is similar to triangle DEF. The following are measurements in right triangle DEF, right? So what I want to do is sketch this, right? So we're just going to sketch triangle ABC. We're going to say it looks like this. Boom, 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 right? So A, B, and C. These are my right angle. And we'll say DEF looks like this. Boom, 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 right? Just a little smaller. B, D, E, F. We have measurements for DEF. We know this is our right angle. We says DE is the square root of 181. That DF is 10 and EF is 9. So then what we could do, it says then what the following is the measurements. What is the cosine of A? So the cosine of A, what we know is the cosine of A, since A and D are going to be congruent because they're similar triangles, that whatever the cosine of A is the same thing as the cosine of D. So we could say the cosine of A is equal to the cosine of D. All right? So then, what's the cosine of D? Well, remember our SOHCAHTOA. SOHCAHTOA, right? And that will tell us what cosine is. It's adjacent over hypotenuse. So let's label the sides here, right? So if we label our sides with D as our resource, right? That's our home base. So that means that 9 is my opposite side. The square root of 181 is across from our right angle, so that means that is my hypotenuse, and that means 10 is adjacent, right? So with this information, we want to use adjacent over my hypotenuse. So we could say the cosine of D is equal to 10 over radical 181. We can't leave that there, right? We have to get it out of our denominator by radicalizing it. So we're going to multiply this by square root of 181 up top and square root of 181 down below, which will give us 10 square root 181 over 181. And that is our answer, right? Because since they're equal, this is also the cosine of A. Boom, there we go. And since it doesn't ask you to simplify, this is what we can leave it as. We're good to go. Next up, it says in this figure, triangle GHJ is similar to triangle PQR. Awesome. If they're similar, it means we could set up ratios, or we could say, hey, their angles are equal, right? This is based on this information. What ratio represents the tangent of h? So once again, let's write so ka toa, right? Whenever you see your trig, you should write out your SOHCAHTOA because it's going to help you out. And now, h is here. Let me figure out, hey, what angle matches up with h in this bigger triangle? It's going to be q. So we know that the tangent of h is equal to the tangent of q. They mean the same thing. And we can find the tangent of q. Let's label our sides here, though, right? So opposite of q is here. 6 is my opposite. Adjacent is going to be 8. And 10 is my hypotenuse. And with our tangent, we need opposite and adjacent. So this is going to equal, which is the tangent of h, tangent of q, same thing, is going to be 6 opposite over adjacent, which is 8. 6 over 8. Or we could simplify this, and it's going to be 3 over 4, or 3/4. And there's our answer. Awesome. Next up, it says consider triangle ABC as shown. In triangle ABC, cosine of A is 4 over 5. What's the sine of B? So if cosine of A is 4 over 5, what we know is, once again, a trig ratios here. So let's write out so ka toa, right? If cosine of A is 4 over 5, right? So A is here. This means our opposite, adjacent, AD, okay? And then tangent is here. Or hypotenuse is here, sorry. Hypotenuse is there. Now, another thing we know about this is in our triangle, our two smaller acute angles here, A and B, they're opposite. So whatever the cosine of A is equal to the sine of B. That's a relationship that we know, that we discovered. So since the cosine of A is 4 over 5, we know that the sine of B is also going to be 4 over 5. So we don't actually have to do any other work here. We're good right off the bat. Our answer is 4 over 5 because the cosine of A is equal to the sine of B, and the opposite is true too. The sine of A is equal to the cosine of B. Next up, it says in right triangle ABC, let sine of B equal R and cosine of B equal S. What is the sine of C minus the cosine of C? So we could use the idea that we just used in that last problem, right? And what we could say is, since B and C are the two acute angles in this triangle, we could say that the sine of B is equal to the cosine of C. And then, I'm going to use a different color because it will help us in the future. We could say the cosine of B is equal to the sine, of C, right? So for this equation here, we could swap things out. So let me write my original, right? Let's write the original here. It is sine of C minus cosine of C. Now let's swap things out. The sine of C, which we have right here, right? I'm going to dot it. Cosine of, or the sine of C could be swapped out with the cosine of B. The cosine of B minus, and my cosine of C, we'll do a squiggle, cosine of C is right here, is equal to the sine of B. So we're going to swap that out, sine of B. And why do we want to swap these out? Because then we could use what they're equal to in our original, where it says let sine of B equal R and cosine of B equal S. Because we just said cosine of B is equal to S, so we could put S minus the sine of B is equal to R, so it's going to be S minus R, and there is our final answer. It's going to be S minus R. All we did was we swapped things out using properties that we learned in the past. Next up, it says a seesaw with the construction shown is being built at a playground. the seating board will be 10 feet long, and the board will make a 30-degree angle when it touches the ground. Find the height of the central support and show your work or explain your answer. Round to the nearest tenth of the foot, right? So we know a couple pieces of information here. We know that this is 10 feet long and that our seating board here, right, is going to be halfway, which means from the middle here to our end here is going to be 5 feet long, which is great for us because we need to know information in this triangle. So what we could then do is set up a ratio with our reference angle of 30. This side is going to be my opposite, and my 5 feet here is going to be my hypotenuse. So what uses opposite hypotenuse, right? Again, so, ka, toa, and you might already see it here. It's going to be my sine. So the way we could write this is the sine of 30 is equal to my opposite over hypotenuse. We don't know the opposite. I'm going to put that as x over my hypotenuse, which is 5. We want to get x by itself, so let's multiply by 5 on both sides. And what we'll be left with, I'm going to also flip it around. These are going to cancel. I'm going to get x equals 5 sine of 30 degrees. Let me just put my little degree symbol in there. And what we could do is we could plug this directly into a calculator, right? Once again, if you've been following me or my videos or anything, the Desmos scientific calculator is my favorite, right? So we could type it in. We get 5 sine of 30. Click enter, and it gives me 2.5 to the dot. So it says round to your nearest tenth. We don't even have to. It already is rounded for us. So 2.5. And what is our unit? It tells us up in the problem up here. It's feet. So let's just put that unit there for safety measures. 2.5 feet. And there we go. The central support of this seesaw is going to be 2.5 feet. So the seesaw is 2.5 feet off the ground in the middle. Awesome, awesome, awesome. All right, so our next problem says the seesaw moves and the angle created by the left of the seating board and the central support is now 70 degrees, right? Which we see in the picture. We have a 70-degree angle right here. It says find the distance from point Q to the ground, which is this dotted line. When the angle created blah, 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 70 degrees. Show your work and explain your answer. So what we want to do is find this distance. What we can do is use the information from the last problem. We know that this pole is 2.5. And we know that from Q to R is going to be 5. What we want to find is this whole entire distance, right? Or actually, sorry, what we want to find is that, actually what we want to find is this distance, right? And then we can subtract 5 away and find the dotted line. So let's do that. What we have to do is set up a using our trig again. So we have our hypotenuse side and we have our adjacent side. So we have to figure out what uses the hypotenuse and adjacent. So let's write our so. Toa, right? Once we write out our SOHCAHTOA, then we can figure this out, right? Because we have hypotenuse and adjacent, which is cosine. We're going to write cosine of 70 degrees is equal to my adjacent, which is 2.5, over my hypotenuse, which we're going to call x. Once we have this set up, we could flip-flop here, and we could get x equals 2.5 over the cosine 70. And what we could do is if you go to your Desmos calculator, you could just plug this directly in. We get 2.5 divided by the cosine of 70. We click enter and it gives me about 7.3. But what we have to do with that is then we have to say 7.3 minus 5, right? Because this will then give us our dotted line. So that's going to give me about 2.3 feet. And that is my answer for that dotted line. Awesome. So next up, it says a maintenance technician sites the top of a telephone pole at a 25-degree angle of elevation as shown. So from the technician, he's staring up at the top of a telephone pole, and the angle he's looking is at a 25-degree angle. To determine the horizontal distance between the technician and the base of the telephone pole. So what we have to do is label our sides here in this triangle. This is my opposite side. Here's my right angle, so this means that's my hypotenuse. And last but not least, the side we're looking for is my adjacent side. So the two pieces we want are opposite and adjacent. We could say what uses opposite adjacent? My tangent. We could set this up. The tangent, 25 degrees, is equal to opposite, which is 75, over what we're looking for, x. Once again, we could flop these. We get x equals 75 over the tangent of 25 degrees. So with this in mind, once again, we could just plug it directly into a calculator. We get 75 divided by the tangent of 25 degrees. And it's going to give us an answer. If we want to round it to the nearest foot, we get 160.8. So if we round to the nearest foot, it's going to give me 161. Whoop, that's a T. 1 feet. There's our answer. Boom. All right, our next problem says on a coordinate plane, a line segment has endpoints P 12, 4 and Q 6, 16. The point M lies on the point M lies on and divides the line segment, so the ratio of PM to MQ is 3:2. What are the coordinates of point M? So in order to do this, what we have to do is cut this up. And what we want to do is cut this line into 5 segments. Why 5? Because if we add 3 and 2, that gives us 5 total segments, right? And then what we could do, so what we have to do is find the difference between these distances. So we want our x's and our y's, right? So what we're going to take is x2 and subtract it from x1. So we're going to get 6 minus 12. Sorry, x1 and subtract from x2, which is going to give me -6. And then we're going to divide that by 5. And then what we're going to do is 16 divided minus 4, right? Which is going to give me 12, and divide that by 5. And what -6 divided by 5 is going to give me is 1.2, or -1.2. Whoops, sorry about that. -1.2. And then what we're going to get here, 12 divided by 5 is going to be about 2.4. And now what can we use with this, right? What we could say is for my x, every time I start at P and I add these, right, to that coordinate, it's going to create another segment, right? And what we want to do is add it 3 times because we want a 3:2 ratio. So we're going to start at P and go 3 times, and that will give me my 3:2 ratio, right? So what we could then do is say, hey, P is at 12, 4. So first time we're going to do minus 1.2 and then plus 2.4. So 12 minus 1.2 is going to give me 10.8. 4 plus 2.4 is going to give me, put our commas here because these are coordinates, is going to give me 6.4. And then we do it again. So that's 1 time, right? So 1 time. We want to do it 3 times. We do it again, minus 1.2 plus 2.4. So I do minus 1.2, and that's going to give me 9.6, comma, add 2.4 to my y coordinate. That's going to give me 8.8. And that's my second time. And one more time we do it. So we do minus 1.2, add 2.4. So this is going to give me 8.4, comma, and here it's going to give me 11.2. And there is our coordinate that would divide this into our 3 to 2 ratio. Bing, bang, boom. Nice and simple. All right, in our next one, it says in the coordinate plane shown, point C, not shown, lies on AB. And what we want to do is we want to divide it again. We want to divide it down here. It tells us we want to divide it into a 3 to 1 ratio. So we want to really cut this into 4 total parts, right? So what we do again is take our x coordinates and subtract them. So 5 minus a negative 7 is going to be plus 7, which will be 12. And then our y coordinates, 6 minus 2, which will be 4. And we want to divide it into 4 parts. So let's do that. That's going to give us 3. And then that's going to give us 1. So what this tells us is we want to go right 3 and up 1. And I'll divide it into the parts. So we go right 3, 1, 2, 3, up 1. We put a point. 1, 2, 3, up 1, put a point. 1, 2, 3, up 1, we put a point. And what do we notice? We have 1 section, 2 sections, 3 sections, 4 sections. And since we want it to be a 3 to 1, we go to our third point here, right? And what are the coordinates of that? It's going to be 2, 5. Our coordinates are 2, 5. And there we go. We got our answer. And that is the coordinates for point C. And our last problem, it says the circle with the center F is divided into sectors. In circle F, EB is the diameter, and the radius of circle F is 5 units. It says, what is the arc length of AED? So we want to find the arc length of this section there. What we need to do first is find our central angle here, our 2 central angles. So up top, we can find this one by doing 180 minus 120, which is going to give me 60 degrees. And this one, we could do 180 minus 30 and 45. So 180 minus 30 is going to give me 150, minus 45 is 105. So this total degree here of angle AFD, angle AFD is equal to 165. Whoops. 165 degrees. And that's going to come in handy in a second. So now what we could do is we need our formula. So the arc length formula, right? So arc length, the formula is 2 pi times the radius, and then we do our theta angle over 360, which is, this is my theta angle, 165. So let's plug in the information we know, right? We're going to get 2 times 3.14. My radius here, we know that the radius is 5. It tells us up here. So we're going to get times 5. And then we're going to get 165 over 360. And we're going to plug this all into a calculator just how it is. Go to your decimal calculator and you type it in. We do 2 times 3.14 times 5 times, we want to do 165 over 360. And we get our answer as 14 with a decimal, right? And now it doesn't tell us where to round. So what we're going to do is we're going to round to 14. And we're going to round to the first decimal place, so 0.4. It's going to give me 14.39 something, something, something. But that's going to come out to 14.4. And there is our arc length. Awesome. That is the end. I wish you guys luck. If you have any questions, comments, or concerns, please let me know. Good luck. Rewatch parts that you need help on. And have fun.